In the last video, we learned about pointers. In this video, we're going to see how the standard library wraps pointers with helpful tools called smart pointers. Remember that one of the primary uses of pointers is for managing objects on the heap. We did this using the new and delete operators. New created an object, and delete would destroy and clean up that object. We mentioned that every new needs to be paired with a delete to make sure we don't leak memory. This can be trickier than it sounds. For a short example, consider a function that uses some object on the heap. We create it at the top of the function and make sure to add a delete for it at the end of the function. But somewhere in between, we have a short circuit check that has our function return early if it can't do what it's supposed to do. There's no delete in this branch, so if we enter this if body, we leak that heap object. In a small example like this, it's easy to see the mistake and fix it, but as your code grows longer and more complex, it's easier for these kinds of errors to slip by. What we'd really like is some way for our computer to track when we're done with that object and clean it up automatically. And this is what smart pointers do. Smart pointers wrap raw pointers and call delete for us in their constructors. This lets us not worry about keeping track of all the places we would need to call delete, as it takes advantage of the normal rules about when object destructors are called. There are three types of smart pointers that follow different models for ownership. The first is unique pointer. This is the simplest, and it wraps a pointer with a single owner. Unique pointer is most useful when you're managing a heap object that doesn't need to be shared with other parts of the code. You can't copy a unique pointer, since that would end up with two objects that both think they're the only owner. If one got destroyed, it would take the underlying object with it, and the other unique pointer instance would be left dangling. So we avoid the whole problem just by disabling copies for this object. To create a unique pointer, we use the makeUnique function. Both makeUnique and unique pointer need to be templated on the type we'll be pointing to. When the unique pointer destructor is called, it calls the delete operator for us. The next type is shared pointer, and as its name suggests, it's used when we need to share ownership between multiple objects. It works using a technique called reference counting, where it keeps account of how many copies of a specific shared pointer exist, and when that number drops to 0, delete is called. This makes it easy to share an object between multiple owners, because the object will be kept alive as long as at least one of the owners still wants it to be there. In our robot and radio example from our ownership video, we could have used shared pointers to let the robots manage the radio themselves and avoid having to move ownership to the main function. Shared pointers might be the most common type of smart pointer used throughout C++. They're certainly the most common when using ROS, as most of the ROS resources are given to us as shared pointer objects. To create a shared pointer, we use the makeShared function. Again, both the function and the type need to be templated for the type of object they'll be handling. The final type of smart pointer is weak pointer. This one is heavily related to shared pointer. A weak pointer is a non-owning pointer to an object owned by shared pointers. To get a weak pointer, we must first have a shared pointer. We can then get a weak pointer to that same object by initializing it with the shared pointer. Weak pointers do not affect the reference count of the shared pointer, so they can't keep an object alive when all of the shared pointers have been destroyed. They can let us check if the underlying object has been destroyed already, and will throw exceptions if we try to dereference a weak pointer to a destroyed object. One neat thing is that a valid weak pointer can be used to get a new shared pointer copy with the lock function. This gives us a way to give objects dynamic ownership over a pointer, where they can own and disown the pointer as needed. In almost all cases, you should prefer using smart pointers instead of using new and delete. Besides handling the proper cleanup of our objects, smart pointers document and enforce the ownership model we intend for our code to use. This goes a long way to preventing bugs when working on complex collaborative projects.